Hey guys, welcome to Lecture 7. In this lecture we'll be learning how to create arrays. So I'm going to call it Creating Arrays. Okay, so a big part of data analysis as far as this course goes will be array-based and matrix-based. So in order to do that, we're going to learn how to use NumPy to create these arrays. So the first thing we're going to do is import NumPy as NP. This will save us from having to type NumPy every single time. We can just write NP instead. One way to make an array is by converting from a list. So I will say make an object called myList1, and let's make a list of 1, 2, 3, and 4. Okay, so now that we have our list, we can make an array. So I will make an array called myArray1. And the way we can make an array is by using np.array, and then we can pass that list as an object. So we can say my_list1, and let's go ahead and see what that ended up being. Great. So now we have an array that we made from the list. So that's one of the ways we can make the array. So let's go ahead and make another list. We'll call it myList2. And in this case, we'll just have it be 11, 22, 33, and 44. And now we're going to make a list combining those two lists we just made. So I will call it my list plural equals my list1 as the first object in that list, and then I'm going to say my list2 as the second object in that list. And looks like I forgot the underscore. Let me add that. And there we go. Okay. So now we have a list of the two lists we made. We can make a multi-dimensional array or a matrix using this. So I can say my array2 is equal to np.array, and I'm going to pass that list of multiple lists. So I can say my lists, there we go. And let's go ahead and see what that multidimensional array looked like, otherwise known as a matrix. Great. So you can see now we have both lists in the array. It's 1, 2, 3, 4, 11, 22, 33, 44. And let's go ahead and see what the shape of that array is. So since it's multidimensional, I can ask NumPy what shape it is by saying .shape method. And so it looks like it's a 2 by 4, which makes sense. So that means every list you passed in that list of lists created a new row. So here was your first row, and then here's your second row. All right, great. So now we know how to make an array and a multidimensional array from a list. So we can also find out the data type of the array. And I can do that by, in the same way I asked what the shape was, I can ask for the dtype by passing the dtype method. And it'll tell me the type of objects that are in that array. There's also special case arrays. So for instance, if you wanted an array of all zeros, you could say np.zeros, and then just indicate the shape of the array you wanted. So if I wanted an array, just a 1 by 5, of zeros, so just a straight vector. And there I have it, my 5 zeros. And if you notice, there's a decimal point there, and that's because they're a floating type. So to show you what I mean by that, I can say np dot, well, I can say my zeros array equal to np dot zeros 5. And then I can check the type. So I can say my zeros underscore array. And we just learned how to check the type. So let's go ahead and make sure they're floating, and they are. So they're floating numbers, which means they have that decimal point there. Excellent. Another special case array is an array of ones, and I can do that by saying np1s. And I can pass the shape here too. So I can say, for instance, a 5 by 5. So I'll make a matrix of 1s, and there you have it, a 5 by 5 multidimensional array. I can also create an empty array. I can do that just by saying np empty, and that'll be the same thing as just asking for zeros there. Okay, and then last but not least, we can make an identity matrix or identity array, and it's always going to be, well, almost always going to be a full matrix, multidimensional. And you can make the identity matrix by using EYE. And since it's a matrix, you'll have to input just a square matrix, so it's going to be a 5 by 5 in this case if I input just the number 5. So I can say Alt-Enter, and then here's my identity matrix, which is just a diagonal of a 1, and then everything else filled in with zeros. And then one way we can make an array that we'll be using a ton in this course is by np.arrange, and what that does is it's going to give you can input a start and a stop and a step size, and it's going to return evenly spaced values within that given interval. So I can say just 5, and in this case it's going to output 0, 1, 2, 3, 4. Excellent. And to get more specific, I could say something like start at 5, stop at 50, and do it in steps of 2. Let's see if it can make evenly spaced. There we go. So 5, 7, 9, etc., all the way in space of 2. So we'll be using this arrange method a lot throughout the course. Okay, so that's how you can create arrays. Just to do a quick overview, you can pass a list using np.array and input the list. You can check the shape and the type of objects in for those matrices or arrays. And then your special case arrays, you can say zeros, ones, empty, I, and then you can also create an array by just using arrange. Alright, that's it for creating arrays. I'll see you in the next lecture. Hey everybody, welcome to Lecture 8. So in this lecture, we're going to be learning how to use or using arrays and scalars. Okay, so first off, we're just going to import NumPy as NP, and then something we can do is say, let's check 5 divided by 2. So in Python version 2, if you were to input this command, 5 divided by 2, notice you'll just get a whole integer there. You're not going to get 2.5 as it should be. If you declare 5 to be a floating point by saying 5.0, and we run this again, Alt-Enter, then we do get the true answer. It treats that as a floating point. In order to take care of that, we can import from the future. I know it sounds crazy, but we can totally do it. So we can say from __ future __. We can import division. So if you're running on Python 3 point whatever x, you won't have to worry about this. It's already going to be standard. But if you're running on Python 2, you're going to have to import from the division from the future to take care of that problem. So now let's go ahead and see 5 divided by 2, and we get 2.5. Excellent. All right, so let's go ahead and create an array. Like we've done in the last lecture, we can say we're going to call this array ARR1, and I'm going to say np.array. And like we learned in the last lecture, we can do it with a list of multiple lists. So I'm going to do just that. I'm going to say 1, 2, 3, 4. That's be the first list that I input, and then the second list that I input will be 8, 9, 10, 11. Okay, so now we got that. Let's go ahead and see what that multidimensional array looks like. So we have a 2 by 4 here. Excellent. So what can we do with that? We can try multiplying arrays. So in this case, we can say array 1 times array. array 1 times array 1, excuse me. So what do we get here? So if you do this kind of command, it's going to multiply every value in the same spot of one array by the value of the other one in the same spot. So for instance, 1 times 1 is 1, 2 times 2 is 4, 9 times 9 is 81, etc., etc. So you can do some scalar operations there in a sense. You can also do subtraction. So we can say array 1 minus R1, there we go. And you'll get a 0, which makes sense because 1 minus 1, 2 minus 2, etc., etc. And then you can do arithmetic operations with scalars on the array. So for instance, if I wanted to say 1 divided by every value in that array, this would be the same thing as saying every value in the array to the power of -1, so creating it as a reciprocal of a fraction. There we go. And that's what we got. So if we look at the original array, 1 divided by 1 should be 1. And then we say 1 divided by 2 should be 0.5. And if we look at some other values here, 1 divided by 10 should be 0.1. So that makes sense, the same as 1 over 10. So you can do that as well. And then lastly, you can also do exponential operations. So you could say that array to the power of 3, so every element in that array to the power of 3, and that's what you get. So 1 to the power of 3 is just 1, 2 to the power of 3 is 8, etc., etc. So that's how you can do some mathematical operations on arrays and also arithmetic operations using scalars. Okay, so we'll be using these throughout the course. Go ahead and do an overview, make sure you understand it, and otherwise I will see you in lecture 9. See you there. Hello everybody, and welcome to lecture 9. In this lecture we'll be going over indexing arrays. Okay, so we're going to import NumPy as NP. Alt enter to get a new cell and run it. Let's go ahead and create a sample array. So in this case I'll just call it ARR, and I'm going to set it equal to np.arrange. And let's go from 0 to 11. So in this case, and then let's go ahead and show it. Think about what you expect to see here before you click Alt Enter. And let's go ahead and see it. Okay, so hopefully you figured out that the index starts at 0. So in this case, calling it all the way to 11 means I would get 10. Here we go, 11 points, excuse me, 0 through 10. And if I want to get a value at an index, I can say call the value at 8, index 8, and that should be equal to 8, which makes sense because if I go 0, 1, 2, 3, 4, 5, 6, 7, 8, I'll end up at 8. Great. So what if I want to get the values in a particular range? I can also do that by inputting a range from 1 all the way to 5. And remember, this should go to 1 before 5, so it should output 1, 2, 3, and 4. Let's go ahead and see if that's true. And it did, so it outputted 1, 2, 3, and 4 in your array. Perfect. And let's go ahead and get the values in a range again. So how about 0 through 5, and that gets us 0, 1, 2, 3, 4. Okay, so that's how you can get values in a range. You can also set a value with an index range. So I can say from the range 0 to 5, I can set all those values equal to 100. So before you click enter, think about what's going to happen. I'm telling Python to say, hey, all the values from 0 to 5, go ahead and set them equal to 100. But remember, you start at 0, so it should be 0, 1, 2, 3, and 4. Those 5 numbers should be equal to 100. And then it'll go 5, 6, 7, 8, 9, 10. So we should expect 5 instances of the number 100, and then 5, 6, 7, 8, 9, 10. Let's go ahead and see what our array looks like now. And we got just that. So here we have the 5 100s, so 0, 1, 2, 3, and 4 were turned into 100, and then we have 5, 6, 7, 8, 9, 10. Alright, perfect. Let's go ahead and just reset this array. So I'm going to say np.arrange 0, 11 again. Let's see what it looks like. So I have my 0 through 10, the 11 points. And now we can do slices of an array. So I can set an object to be equal to slice underscore of ARR and set that equal to the range from 0 to 6. So in this case, I would expect slice of R to, or array, depending how you want to say it, to be equal to 0, 1, 2, 3, 4, 5. So those are 6 values there. And then let's just type it out so we can see what that looks like. Okay, and there we have it. Here are the 6 values, 0, 1, 2, 3, 4, 5, and now we created a slice of the array in that same fashion. We can go ahead and change the slice. So I can say slice of R or array. I could say, using a colon, say all the elements in that array are now equal to 99. And let's go ahead and check if that is what happened. And that's the case. So using that colon, you can select all the elements in your array. So now note that the changes also occur in our original array. So what do I mean by that? I'm going to show you the original array. Now you might be thinking, whoa, that's weird. I was only changing values in slice of array, not in my array itself. Well, in NumPy, this data isn't copied. It's just a view of the original array. So this avoids memory problems. That way you don't have several copies of your array floating around. You only have one copy of your array, and if you grab slices of it and change the elements, it's going to affect your original array. So that's something to really keep in mind when you're messing around with arrays. If you don't want that to happen and you want to get a copy, you got to be explicit. So if I say ARR copy equal to ARR, that will still affect your original array. It's not going to actually make a copy. What I have to do is explicitly say copy. So dot copy, parentheses, no extra arguments. And then I can look at this array, and now I have a copy of it. Alright, great. So let's learn about indexing in a 2D array. So let me make an object called ARR underscore 2D and use np.array. And then as we've done in the past, I'm going to put in several lists, so I can say something like, let's see, let's go ahead and go in powers of, or counts of 5, so like 5, 10, 15, that'll be one list. Then 20, 25, 30, that's another list. And then my next one I can say 35, 40, 45. Alright, and then let's go ahead and show that by typing it out. Alright, excellent. So now I have a 3x3 2D array. Awesome. So how can I index this? I'll type out my R underscore 2D, and if I want to see a row, I can type in the index of that row. So think about for a second before you click Alt-Enter what this should be. And remember, in Python and NumPy, your index starts at 0. So what do we expect to see here? We see the row of 20, 25, and 30. So that makes sense because your index starts at 0, and what I mean by that is if I called 0, I would see the first row here, 5, 10, 15. So here's your 0 index row, here's your 1 index row, and then here's your 2 index row. Alright, great. What if you want a individual element value? Well, you can do that as well. You can just say the row you want, and then also ask for the column you want. Okay, so think about it for a second. What value should this get me? I'm asking for index 1 row and index 0 column. And hopefully you got that it was going to be 20, so that makes sense. Here's my index 1 row, and then that was my index 0 column. Great. Okay, so we can also do 2D array slicing. So how does that work? Let's go ahead and see that 2D array again. So there's my 2D array. Let's say I wanted a 2-2 shape array from the top right corner. So I wanted the 10-15 and the 25-30 as its own 2x2 array. So I can just do that by taking a slice. And so what I'm going to ask for is everything up to 2, and then 1 and beyond as far as the columns. So let's see if that works. And it does. Excellent. So if you look at, for instance, the columns here, I asked for the 1 column index and everything beyond it, so that would be these 2 last columns. And so that's what allowed it to take the 10-25 and the 15-30, and then to cut off the 40 and the 45, I asked for everything until the second indexed row. Okay, great. Now what else can we do? So we've been able to take some 2D array slices. We can check out the bottom row if we wanted to by saying 2 there. That would have been the bottom row. Perfect. And we can go on to something called fancy indexing. So fancy indexing, I'll show you what it means. So we can say something like, let's just make this array another 2D array. Won't put the underscore to differentiate it. And I'm going to make a zeros array. And if you remember from some previous lectures, we can say zeros. Then let's go ahead and input the size. So we'll make it a 10 by 10. Let's go ahead and see what that looks like. Okay, here's my 10 by 10 2D array of all zeros. And it looks like they're all floats. That's why there's a decimal there. And now I can get the length of the array. I can say object array length underscore length equals R2D shape of that first. And if I look at that, I should get, whoops, equal to 10. So it has a length of 10. So that's how I could get the length. So now we can set up the array. So I'm going to say for I in range length of the array. So for I in range 10 basically is what I'm saying. That array element value of I equals I. Okay, so now that we've done that operation, I'm going to check out the multi-dimensional array, but go ahead and think about what we just did here as far as this function. So we said for every I in the range R length, and that R length was 10, go ahead and set that element there equal to 1. So what should that do? That should give you straight ones. Alright, so that makes sense so far. What if I said equal to I? Now let's go ahead and see what happened to our array. Go ahead and think about what this should look like before you check it. Hopefully you thought about it right and you got 0, 1, 2, 3, 4, 5 all the way to 9, and then everything across is yet the same. So we only change those across the rows themselves. So every row, every value in that row equals that count number. Okay, So fancy indexing allows for us to do the following. So we can say something like ARR2D and just index it by the values in that row. So we can say 2, 4, 6, 8. Great. And so that will give us the second, the fourth, the sixth, and the eighth rows for indexing. And we can do this in any order, which is why we get the term fancy. So it doesn't have to be in order. We can just do random rows here. So I can say 6, 4, 2, and 7. And that will return the 6, 4, 2, and 7 index rows. And that's fancy indexing. So main takeaways here are, again, we've reviewed how to create arrays, and the main takeaway is how to index. So remember, this is really important. If you want to explicitly make a copy, you got to state that .copy. Otherwise, changes you make in slices of the array will affect your original array. And then for indexing, you can ask for the row, or you can get the row and the column, and you can use colons to get certain slices or chunks out of your multidimensional arrays. And that's it for indexing arrays. And we finished off with fancy indexing. Okay, next up we'll have lecture 10. I'll see you there. Hey guys, this is lecture 10, array transposition. So in this lecture we'll be learning how to transpose arrays in NumPy. So let's go ahead and start off importing NumPy as NP. Alt-enter to get a new cell. Let's create an array, and we'll use arrange to do this. So that's going to give us 50 points from 0 to 49. And then let's reshape it into a 10 by 5 matrix, and then we'll just show it. Cool. So we have 0 to 49 in a 10 by 5. Since the index starts at 0, that's why it doesn't go all the way to 50. But we have 50 points, 10 times 5. So to transpose this matrix, it's actually pretty easy in NumPy. All we got to do is select our matrix and call .t onto it. And then you see it's been transposed. So the first row of our previous array has now been transposed as the first column. Cool. And NumPy also allows you to take dot products of arrays. So you can do that by calling np dot. And so we can do the dot product of the transposed array with our original array. And here we have the dot product of those two arrays. And we can also make 3D matrices. Even though we won't be using it that much in this course, we can go ahead and just see how it works. So we'll make a 3D matrix. Again, let's call arrange 50 points, and we'll reshape it as a 5 deep matrix with 5 by 2 arrays. So let's see what that actually looks like. So here we have basically the 5 slices of that 3D matrix, and each slice consists of a 5 by 2 array. And if you want, you can also transpose a 3D matrix. In order to do that, we can call transpose on that matrix. And we'll have to specify which axes to use. So for instance, if we transpose it this way, we'll get on that first slice, all the first column will be all the 0, 0 of every individual slice. So if we look back at the original 3D array, matrix, we had a 0, a 10, a 20, a 30, a 40 as the first row and first column indexed value. And now that's become the first column of that first slice. You can kind of see how that same transposition carries out through the rest of the array. And last but not least, if we want to get really specific on swapping axes in an array, we can actually call swap axes onto it. To show you what I'm talking about, let's go ahead and make another array real quick. We'll just call this one, let's see, we'll have it be 1, 2, and 3, and we'll show it. Alright, so we have our array there. And let's say you wanted to be specific on how to swap axes, you can actually call swap axes. So we can swap the 0 axis for the 1 axis. And let's see what happens. And now you have a vertical array. Cool. And that's about it as far as array transposition. I'll see you in the next lesson. Okay guys, this is lecture 11 now. And this will be about universal array functions. So let's start off by importing NumPy as NP, Alt Enter, and let's go ahead and make an array to start off with. We'll just call 11 points and show it so we can have 0 through 10 in our array. So universal functions are basic functions that you can apply to every value in an array. So for instance, we can take square roots by calling np.sqrt, and we can call it in our array, and now we've taken the square root of every value in the array. So if we look at 4, we should have a 2 there, yep, and 9 gives you a 3, cool. So what other things can we do? We could possibly take the exponential of every value in the array, so basically have e to the power of the number, the value point in that array. So if we run that, that's what we get. First value makes sense, right? Because e to the power of 0 is just 1. So that worked out. There are also binary functions. Those will require 2 arrays because of the term binary. That makes sense. So how about, in order to see that, we'll create a random array. In order to do that, we'll call NumPy using np. Then we'll call random from the NumPy library. And then we'll call a random normal distribution. And we'll have it be 10. And let's go ahead and see that array. And if you don't quite get what we just did here, we'll be going over it a lot more throughout the course, so don't worry about that too much. Let's go ahead and Alt Enter. Cool, so now we have our array that's a normal distribution of some random numbers. Let's create another one, np.random.randn of 10. And let's go ahead and see that as well. Cool, there's our other guy. So in order to do some binary functions, all that means is functions that use 2 arrays. So for instance, adding arrays. So this will add every value of A to every value of B. So this first value of A to this first value of B. Let's go ahead and see how that looks. So we have negative 0.3 blah 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 plus 0.11 gets you negative 0.23, etc., etc. Other things we can do is find the max or min between 2 arrays. So in order to do that, we can say np.maximum called 2 arrays, and this will find the maximum between the 2 array values. So to see what I'm talking about here, if we look at our original arrays A and B, it will compare the values at each index. So the first one was negative 0.35 in array A and 0.11 in array B. So it's going to compare those and see which one was the max, and then set that as the value for that array you just called. And it's going to do that for each of the values comparing A and B. And you can also check for minimums just by calling np.minimum. So for a full extensive list of all the universal functions, you can check out the documentation. So I'm just going to edit, copy, and edit, paste the website here. And again, like always, you can just click on the links to see the IPython notebooks from GitHub. If we want to see this website, a little trick we can do is import web browser and then call web browser to open that website link. Let's see if that works. Yep, looks like it did. So here are all the available math operations, these ufuncs, universal functions. So you can add, subtract, multiply, divide, take the log of the sum of the exponents, find remainders, find signs. There's a whole bunch of stuff you can do. Take square roots, get the squares, and we'll be using this as we need them. And you can also do trigonometric functions, get the sines of the values, the cosines, the arctans, etc., the hyperbolics, and then there's comparison functions as well, which we'll look into later. So you can go ahead and check out the documentation on these universal functions in case you're looking for extra ones or more info. Alright, so that'll be the end of lecture 11, and I'll see you at the next one. Array processing. In this lecture, what we're going to do is mesh from those arrays so we can get kind of a grid plot and see what that looks like. And then we'll do some other processing with arrays, some statistical processing, and then just messing around with some Boolean stuff as well. So this is going to be a little bit longer lecture than the last two, but so let's get to it. We'll start off by importing NumPy as NP, and then we're going to import matplotlib. Whoops. Matplotlib, and we'll import the pyplot library from it, and we'll import it as PLT. So we're going to do this because we're going to be visualizing some of the grids and meshes we'll be making. And then in order to see those visualizations in the IPython notebook, we need to call matplotlib inline so we can see it inline with everything. Alt-Enter, and it's imported it. Cool. And don't worry too much about the matplotlib and visualizations in general. One of the last sections throughout this course will go into much greater detail into visualizing data. So let's start with the creation of a grid. We'll do that by setting one side of the grid, points. So these will be the points along one side of the grid. We'll do that by calling numpy.arrange. So we can do our start, stop, and our step value. So we'll start at -5, stop at +5, and let's go in steps of 0.01. Alt-Enter. Cool. So we have our points, and then we'll create our grid. So our grid can be a points by points grid. So to show you what I mean by that, we'll call dx and dy, and from NumPy we'll call mesh grid. And what this will do is return coordinate matrices from the vectors we give it. So the vectors we're going to give it is just points by points. And to see what that actually did, let's go ahead and take a look at dx. Cool. And you'll see that dx is basically a matrix where all the rows go from -5 all the way to +5 in those 0.01 steps. and you'll see that dy is the same thing, but now it just goes along the columns instead. So this will help us make our grid. So how about we do an evaluating function? So we'll say that z is equal to np.sign of dx. So we'll take the sign of all the dx values. If you remember from one of the previous lectures, this is just a universal function, happens to be trigonometric. And we'll do np.sign of all the dy values too. And then we'll take a look at, we'll see what z actually looks like. So Alt Enter, cool. So these are our z values. And in order to get actually looks like, because these numbers can be a bit nebulous, we can plot this. And in order to plot this, we'll call PLT, and we'll do an image show, so that'll be IMShow, which is a good way to plot this kind of data, basically a matrix. So we'll call it Z to it. See what that looks like. Awesome. So now you can see how this is basically a sign along both the X and the Y. You can see how it has its peaks and valleys. If we want to see what that what these colors actually mean as far as values, we can plot it with a color bar. So let's call that ImShow again. Plot it with the color bar, and the last thing we're going to do is also give it a title. So we can do that by saying plot.title, and we'll say that's the plot for basically sine of x plus sine of y. So let's take a, oh, forgot to close that string there. Nice. And so now we can get a much better idea of what this image is actually showing us. So we can see the peaks here in red and the valleys. Testing is learning how to use NumPy where. In order to do that, we'll create two arrays. So let's create an A array, np.array, and we'll make this just a simple 1, 2, 3, 4. And then let's also make, scroll down a bit, also make a B array, and we'll say this is 100, 200, 300, 400. That way we can tell the form, but also know which values go with which array. So we'll input those arrays, and we'll create something, we'll create a Boolean array. So a Boolean will allow us to input true and false conditions into an array. So we'll call it condition, and in this Boolean array, what we're going to do is just input Boolean values. So true, true, and false, false. So we have our Boolean array now, and we can use this for something called a list comprehension. So what that will allow us to do is, let's say we want to make an array where we choose the A value if the condition is true. Otherwise, we choose the B value. So to show you what I mean by that, we'll say eval if condition is met, else use the bval. And since we haven't defined what aval or cond or bval is, we'll say that's for every a value, bval, and cond in, and we'll use zip to input multiple arrays, a, b, and condition. And whoops, have some invalid syntax here for let's just get rid of that. That actually goes at the end, since the whole thing will be, the whole answer is an array. So Alt Enter. Cool. So before I show you the answer, let's go ahead and think about it, see what we should be seeing. So what answer is, it's gonna say, hey, in this array, show me the a value if the condition is met. Otherwise, show me the b value. And it defines a value, b value, and condition as each value in the a, b, and condition array. So if we think about this, let's see what that first value of this array should look like. A value if the condition. So it says choose the a value 1 if your condition is true. Otherwise, choose the b value. So you would expect the first value of this array to be 1, since that's true. And then again, if you go along to the second value of that array, a value, whoops, 2, if the condition is true. Otherwise, choose b. So it should be 1, 2. And then a value if condition. So on the third one, the condition is false. So we would expect it to choose the b value there. So we should see a 300. And then last, on the fourth one, again, it's false. So it's not going to choose the a value, it'll choose the b value. So let's see if we're right. We should see a 1, a 2, a 300, and a 400. And that's exactly what we see. So just take a moment to really understand what's going on here. We're just using a list comprehension to have a little bit of Boolean logic in this array for each of these values in these three arrays here. Cool. So now we'll use NumPy where. So to show you what that looks like is we'll have another array called answer2 np.where. We'll pass a condition and then we'll say a, b. So what this NumPy where does is basically the short form of this long list comprehension array. So it's going to say where my condition is met, choose A, otherwise choose B. So where my condition, true, choose A, 1, otherwise choose B. So we should expect doing this command to see the exact same thing. And let's see if that is true. We'll do Alt Enter, and then we'll show answer 2. Yep, and that's the same thing. So you can see using NumPy, we can get that same kind of logic in a much more convenient fashion. So take a moment to see if you understand what just happened, and try inputting different conditions, different array values, play with it, see if you can predict the right arrays that come up on 2D arrays for manipulation. So from NumPy .random, I'm going to import the normal random distribution, because we'll be using that in a bit. And now I'm going to make an array. Now I can just call random without calling np.random, since I imported it specifically. And we'll make a 5 by 5, and let's go ahead and show what that matrix looks like. Cool. So this is this matrix came from a random normalized function. Cool. So, using the same kind of where command and logic, I can say something like np numpy.where. How about where this we'll have to feed a condition, so we'll say where the array or this matrix was less than 0, make it a 0. Otherwise, leave that array value. So we have our condition, the first option to replace it, otherwise do that. So let's go ahead and see what happens. Cool. So if you look on the original array, everything that was negative is now a 0. So this is a useful tool if you ever want to clean up your data. It's also used in Pandas, which is the module we'll be learning more about later. And it's just a useful thing to keep in the back of your mind. Let's create another array to go deeper into some other statistical processing stuff we can do. So we'll have np.array, and let's make it 1, 2, 3. Let's have it be a 3 by 3, and then we'll say 4, 5, 6, and then that last row will be 7, 8, 9. And let's show it just to see, make sure we did it right. Yep, so it's a 3 by 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's see what happens if I call sum on that matrix. I get 45, so it summed up every value in that matrix. I can also do it along a specific axis. So for instance, if I wanted to sum up everything in the columns, so I wanted to sum up 147, 258, 369, I could say array sum and specify that axis. So we'll say along the 0 and see what happens. Yep, and that's what we get. So 1 plus 4 is 5, plus 7 is 12. So this is just adding it up along the columns itself. There's other things we can call, such as the mean. So this will give us some statistical information. So the average of all that is 5. It's a useful thing to call. We can also call the standard deviation using .std. We get our standard deviation. If you want, you can also call the variance using .var. Do this true and false ones. So to show you how this works, let's go ahead and make a Boolean array, np.array, and we'll have it be, let's just say true, false, true, so it alternates a bit. We'll call that Boolean array. And we'll call any on this. So what any is going to do is it's going to return a Boolean, either true or false, if anything in that array was true. So since there are trues in there, we'll expect it to return true. Let's see if that works. Yes, it does. Similarly, we can call all. And this will return true only if all the values are true. So this should, we'd expect it to return false on the Boolean array, since there is a false there, and they're not all true. And that's what we got. Cool. Finally, you can sort arrays. So in order to see that, I'm just going to put a little comment here so we can know where we are at. We can say, let's make an array. It's just a random 5, and we'll see it. Alt to enter. Cool. So you see it's not sorted right now. So in order to sort it, we can call dot sort, and then we'll see what happens. So now it's sorted it from least to greatest. I know this is a lot already, but we're almost done with this lecture. We can use unique. So let's make an array called countries. And let's say we have France, Germany. Let's get the US of A in there as well. Russia. We'll put USA again, and you'll see why in a second. We'll put in Mexico. And then finally Germany again. Let's go ahead and input that. So now we have this, basically this array of countries. We inputted a list of countries and transformed it into an array. If I wanted to find out which countries were unique in this array, I could call NumPy dot unique on countries, and it'll tell me which ones only appeared once. So let's see what happens. I'm sorry, it'll tell me which unique values you have. So you have France, Germany, Mexico, Russia, and USA. So it'll give you each of the unique values in that array. And last, we can also use NumPy dot in 1D. So this can test values in one array. To show you how this works, let's pass France, USA, let's call it, I don't know, Sweden, and countries. So what this command will do in 1D, it's going to check if France, USA, and Sweden are in this countries, a one-dimensional array. So it's going to say, is France in countries, is USA in countries, is Sweden in countries? So let's think about what it should output before we see it. Is France in countries? Yes, so it should output true there. Is USA in countries? Yes, it should output true. Sweden is not in the countries array, so it should output false. So we should get an array that says true, true, false. Let's see if it works. Yep, true, true, false. Alright, awesome. So there was quite a bit in there. We just learned a lot. As always, you can check out the link to the IPython notebooks on GitHub and look at them and play around with some more stuff. Alright, I'll see you in the next lecture. Hey guys, welcome to lecture 13. This lecture will be just a quick lecture on array input and output, so how to save arrays and how to open them beyond just an IPython notebook. So we'll start off by importing NumPy as np. Let's go ahead and do that. Alright. Let's just create a quick array. We'll just say np.arrange. Just make it 5 points. Take a look at what that looks like. So we have our array of 0 through 4, 5 points. If we wanted to save this array, all we gotta do is call np.save, and we can save it as my array, and then choose which array you want to save. So the actual object was ARR. And so now that's saved as an array. To show that it's saved this actual array, let's go ahead and make another array with the same name, and we'll have it be 10 points long and show you what that looks like. So now if I call ARR, it shows a 10-point array of 0 through 9. Let's make sure that we did actually save my original array, which was 0 through 4. And if we wanted to load that, we just use np.load, and we call that file. Now in order to get the actual file, you have to use the NumPy extension, which is .npy. So this was the name of the file, and then if you want to actually load it, you gotta call the extension as well. So let's see if that works. Yep, and it did. Here's our original array that we had saved. You can also save multiple arrays. So for instance, let's say array1 is equal to np.load myArray.npy, and then we'll see what that looks like. And then let's set array2 equal to that 10-point array. Let's go ahead and see what that looks like. So now I have two arrays. If I wanted to save both of them, I can. I can save them in a zip file. We're going to use save again, but this time save with a Z, saves. So it's going to save it as a zip file. You're going to name that zip file, so we'll call this zip array. And the file extension you're going to use here is npz. And then you're going to choose which arrays to save with it. So we can call our first one, let's just say it's X, and that will be the first array, and we'll have the second one called Y, and that will be array 2. So let's go ahead and see if that worked. Yep, it did. If I wanted to load multiple arrays, I can just do that using the load function. So let's go ahead and call let's call it an archive of arrays. And then I'm going to load that zip file I just saved. So it's going to be zip array.npz. Let's see if this works. So it did. So let's say I wanted to look at that first array. Since I saved it as X, I can just call it archive array. Just call X here. And there's my first array. And then similarly, I can call my Y, and I should get the second one. And I do. So that worked out well. And then one last thing, you can also save and load text files in case you don't want to save it as an array. So let's just make an array. Actually, let's make a matrix using the array function. So we'll just have it be a 2 by 3. So we'll say 1, 2, 3, 4, 5, 6. And then let's just take a look at what that looks like now. Cool, we have a 2 by 3. And if we want to save it as a .txt file, a text file, we can say save txt. And then we'll give it a name. We'll just say my text array .txt, since it's going to be a text file. We'll choose the array or the matrix we're going to save it as. And then if we wanted to save it as a text file, we can signify a delimiter. So what the delimiter is, it's just basically what's separating each value. So in your text file, when you see it, you're going to see that it's just a bunch of numbers, and they're all separated by a symbol, or such as a comma. So in this case, we'll signify that the delimiter is a comma, just like a comma separated variable file, or .csv. Let's go ahead and do that, see if it works. Yep, cool. And now let's just take a look at what we save. So if we wanted to load a text file, you can just say load np.load text. And let's load my text array dot text. And then I'll signify that my delimiter, the symbol that's separating each individual value, was just a comma. And then let's see what that looks like. So it says error, NumPy doesn't have a load txt text. Sorry about that. So it's load txt, not load text. So let's try that again. So we have a txt file. It should just be load txt. My apologies for that. And there we go. Now it worked. And these periods here, these dots, is just to signify that it's a floating number. It's not an actual delimiter. All right, cool. So just a quick overview. We learned how to load and save arrays either as special NumPy file formats .npy or multiple arrays as .npz, or we can also load and save them as text files .txts. And we'll learn more about loading in other formats in future lectures, such as Excel files. All right, I'll see you at the next lecture.